Welcome to Chapter 2, where we are going to be discussing states of matter. Any one of our elements that are found on our periodic table has the ability to exist in all the different states of matter. So keep that in mind as we go through. Only elements do this. Other things, such as tables or something, you can't liquefy a table. It breaks the chemical bonds in different ways. But all elements can definitely exist in all states of matter, as well as some compounds. There are 5 states of matter, 3 of which you're probably used to hearing. Uh, Plasma you might have heard about. BE condensates, fairly newer discoveries are being made in that category, but our book does not go into it. So our 5 states of matter are solids, liquids, gases, plasma, and BE condensates. You can tell that BE condensates are fairly new because they didn't even update the title of my slide. The 4 states of matter, right? Yeah, so there's actually 5, so make sure you fix that, please. Our first state of matter we're going to discuss is the solid. Solids are going to have fixed arrangements. Their particles have so little thermal energy, so little movement to them that they can't really break away from each other. Solids are going to have a definite shape because of this, and their volume's not going to change. So whatever container I put a solid in, it's still going to look the same shape, and it's still going to have the same volume. There are 2 types of solids, so we are going to break down solids into 2 types. We have crystalline solids and amorphous solids. Crystalline solids do not have crystalline solids have a crystal structure to them. Their particles are rigidly stuck together where they need to be, and they just kind of vibrate back and forth in their small little spot there. While amorphous particles do not have a regular structure. They still are stuck there and just kind of vibrate in their spot, but their structure is more of an irregular pattern. So crystalline solids have crystals, amorphous solids don't. Going into some examples, crystalline solids. Again, think about crystals. Our first picture up here, this is granite. Granite is a crystalline solid. Also, you're probably familiar with table salt. That comes in crystals as well. So table salt does, sugar does. This is cobalt-2 sulfate. Those are my blue crystals that you might have seen me having around every now and then. That is also a crystalline structure. And of course, diamond. I bring diamond into the picture because diamond is a form of carbon. However, we do have other forms of carbon that are not crystalline solids as well. So amorphous solids, you get your plastics. So anything that's really made of plastic is going to be an amorphous solid. You get your peat, which is a form of carbon, again, as well as coal down here. Both are forms of carbon. They do not have a crystal structure, though, so they are amorphous. Rubber bands, again, that elasticity property they have, that's because they're amorphous. And glass. Glass is also a amorphous solid. A lot of people think glass is more of a liquid because it has a viscosity, they say, and it flows because old glass has like a heavier bottom than a top. That's a misconception. Glass is a solid, it's just amorphous, and normally it has different heavy bottoms on top because they just weren't that great at making glass back then. But it does not flow, so it is a solid. It's just amorphous.